This video is going to teach us how to identify intercepts. So the two different forms of quadratics we've learned so far are intercept form, we can see the two sets of parentheses, and standard form. So there's tricks to be able to identify intercepts from either factored form and standard form, and I'm going to go over those with us now. So when we have a quadratic written in intercept form, it's super easy to identify the x-intercepts. All we do is take the value next to the x in each factor, and we're going to flip the sign. So here we have x minus 3. We must include the sign. So here I have a minus 3. Over here I have x plus 2, positive 2. All I'm going to do is I'm going to flip the sign. So instead of having negative 3 as my x-intercept is going to be positive 3. And whenever I have an x-intercept, so at 3, this is a point on the x-axis. So the y value must be 0 because the definition of an intercept is lying on the axis, meaning I can't go up at all into the y values. Y must be 0. So whenever we have an x-intercept, the y value is always 0. So easy. I took the value, I flipped the sign, negative 3 turned positive 3, the y value is always 0. And this is one of my x-intercepts. I'm going to do the same thing here. Here I have positive 2, so I must flip the sign. Instead of positive 2 now, it's going to be a negative 2. And again, it's lying on the x-axis, so the y value is going to be 0. So negative 2, 0. And that's it. So from intercept form, that's how we identify our x-intercepts. Standard form allows us to very easily identify the y-intercept. All we need to identify the y-intercept is our constant value. So this is going to be the value in the standard form quadratic that has no variable. So here I see my value is a positive 3. No flipping signs. I keep it exactly as it is to identify y-intercept. And so my y-intercept is just 3. So y-intercepts lie on the y-axis. So that means for a y-intercept, the y value, that's your y value, the x value is always 0. I don't move side to side x value to keep it on that y-axis. My x value is always 0. So I have 0, 3. 0, 3. Intercepts always have one of the coordinates as 0. So in an x-intercept, you have the x values and the y values are 0. In a y-intercept, you have the y value and the x value is always 0. So those are the tricks to finding the intercepts from both intercept form and standard form. We're now going to go through a few practice problems so I can show you what this looks like, and this will help you directly with the problems that you're about to complete on your own. So first here we have a function f in standard form as well as factored form, and I'm going to identify the x and y intercepts. So using standard form, which is first, I can easily identify my y-intercept. All I do is I take the constant value, so that's my value here without a variable, and it's a positive 3. So I know that my y-intercept is going to be 0 because in a y-intercept I have the y value. So x value 0, y value 3, and that's it. And my x-intercepts I can easily find from factored form here. So I take the value next to the x, I have a positive 3 and I have a positive 1. I like to circle them so I don't forget the sign. So positive 3, we need to flip the sign, so it's going to become negative 3, 0. And positive 1, I need to flip the sign. It's going to become negative 1, 0. And those are my x-intercepts. I wrote them over here, but I'll transfer them over here as well. So negative 3, 0, and negative 1, 0. So again, in x-intercepts, you always have an x value as a number, and y values are 0. In y-intercepts, you have the y value, the x value is 0. Now, this kind of problem allows us to check our work and make sure we really did it right because it gives us the graph. So here I have a y-intercept at 0, 3. Let's make sure, do I really have a y-intercept at 0, 3? Yes, I do, because I can see that the graph of this function really does cross that y-axis at 0, 3. Now I need to make sure that my x-intercepts are really negative 3, negative 1. And if I look over here, I do see that that's true. I have an x-intercept at negative 1. and negative 3. So now I can see that I did my work correctly here. It matches with the graph. All right, now let's look at another one. So here I have x squared minus 5x and x times x minus 5. Although it looks a little bit different, this is my standard form. Again, it doesn't have all three terms, but I do have that x squared, so this is standard form. And this is factored form because I have two factors being multiplied together. Even though there's not two sets of parentheses, I have one value being multiplied by the second value. Everything inside parentheses counts as one factor. All right. So I need to find my x-intercepts and my y-intercepts. So first, to find the x-intercept, I need to use factored form. Here I have x, and this is ultimately the same as x plus 0. If there's not a second value here, that's really like x plus 0 in parentheses times x minus 5. So if that helps to rewrite this to visualize, instead of having a x by itself here, we can rewrite it like that, plus 0. So here I have positive 0. That means my x value is just going to be 0, y value is going to be 0. So I have x-intercept at 0, 0. And then here I have the actual value. I have negative 5. So I must flip the sign. So instead of having negative 5, my intercept is going to become positive 5, comma 0. Now we need to find the y-intercept given our standard form. So I have x squared minus 5x. So to find a y-intercept, I need a value that does not have a variable. I don't have that c value here, or it doesn't appear that I do. I have x squared minus 5x. However, when it looks like there's nothing, it's really just plus 0, just like how we did down here. So this is my value that does not have a variable on it, the 0. So I have a y-intercept at 0, comma 0. Now let's use the graph and make sure we did it correct. Do I have a y-intercept at 0, 0? Yes, I do, because this is the point that's touching my y-axis. And then do I have an x-intercept at 0, 0? Yes, I do. Notice how the y-intercept and x-intercept share a point. That's because this point here at 0, 0, the origin is on both the x-axis and the y-axis. And then I also should have an x-intercept at 5, 0, which we can see that I do. So I have done this all correctly. All right. Two more quick examples that will help you with number 3 and 4 of your own practice problems are right here. So what if we're given these without a graph now? We need to be able to do this without just looking at the graph, without having the graph to necessarily check our work. So here I have intercept form. The intercept form, I easily can find the x-intercepts. So again, I'm going to take these two values. Negative 3, I need to flip the sign. So I'm going to have an intercept at positive 3, comma 0. Again, we are finding the x-intercepts. So the value that we're using is going to be the x value. The y value is always 0. Same here. I have positive 2. I'm going to circle it, make sure I don't forget a sign. And I need to flip the sign. So instead of positive 2, it's going to be negative 2, comma 0. And those are my x-intercepts. Now I have standard form. I can easily identify my y-intercept. My y-intercept is the value that doesn't have an x on it. So again, making sure that you're including the sign that's in front of the value every single time. So this is a negative 6. For y-intercepts, we have it gives us the y value. So the y value is negative 6, the x value is 0. And lastly, how do I identify both the x and the y-intercept from a value just in factored form? Here's a trick. So first things first, let's do our x-intercepts easily. I'm going to use both values, positive 3 and positive 3. So I'm going to have intercepts at negative 3, comma 0 and negative 3, comma 0. Notice these will be the exact same coordinate. It'll be 1 point, but you can write it twice if you'd like. If that's helpful, you could also just leave it at just writing it one time. But how do I find the y-intercept now from factored form if I don't have it in standard form? Well, here's a trick. Y-intercepts always have which value as 0? X is always 0 in a y value because, again, in a coordinate point we have x, comma, y. So in any y-intercept, the x value is always 0 here. Functions are written as such. Y equals x plus 3 times x plus 3. So if I'm looking to solve for the y-intercept and I know at the y-intercept x is 0, all I have to do is plug 0 into my x's. So I have 0 plus 3 times 0, 0 plus 3. 0 plus 3 is just 3. And 0 plus 3 is just 3. So I know y is equal to 3 times 3. Essentially, you can ignore the x's and just multiply the two values together to find your y-intercept. 3 times 3 equals 9. So I know I have a y-intercept at 9. So again, the y-intercept has the y as the value and the x is 0, just like how we plugged in 0 into these. So when x is 0, y is 9. If that was a little confusing for you, you can also do the old school method without that trick of turning the x's into 0 and multiplying by expanding this out. So we have x plus 3 times x plus 3. You can put it in standard form if you prefer to have it in standard form and just pick that number without the x. So if we put this in standard form, we have x times x, which is x squared, x times 3, which is positive 3x, x times, or 3 times x, which is going to be another positive 3x, and 3 times 3, which is positive 9. So then we have x squared plus 3 is 6x plus 9. And again, the y-intercept is the value with no variable here, so I have a y-intercept at 9. So again, the y value would be 9, the x value is 0, and this is my y-intercept. But we could see it matches here exactly what we did by just making the x 0 and multiplying those second values together. Alright, and that's how you find x and y intercepts. I went through similar problems here that you're going to do on your own. So as you go through and do the next problems on your own, please come watch this video again if you need help.